This section's the Objective-C primer for welcome to the welcome week to iOS. I've got a lot of stuff I've got to go over, and I apologize. If anybody has any questions, please don't hesitate to raise your hand, and I'll do my best to stop things, go over your question, and then move forward. The first part is the announcements. In-puzzle feedback should be back this week if you don't already have it. The iOS setup project that David mentioned earlier is released, and don't forget your Android Student Choice project is due, and the late policy is, a point every minute you're late, so don't be late. And now tonight we're going to run over Xcode and the debugger. We're going to go over the Objective-C primitive data types, a little bit more than David did in class, as well as Objective-C classes, objects, the foundation collections, and then some more of the Objective-C designing a class, similar to what we saw with David, hopefully in a little bit more depth. First thing, this is the link to download the Xcode. If you're having trouble finding it in the App Store, otherwise, the App Store, search for Xcode, you'll find it. It pops up nicely. It's simple to install. The nice thing with 4.3.1 is it installs under Applications as opposed to previous versions of Xcode, which were in the developer area. The downside is that a lot of the things that previously were pre-installed with Xcode have to be installed yourself, and we'll go over that briefly. We can get the blurb about all the nice things that Xcode gives you, how to look at things, but I figure it's much easier if I just put Xcode up in front of you and we can all look at it together. Oops. All right, so here is Xcode with some sample code. We've got our, let me zoom in so you can see it a little bit better. We've got our different areas. We've got our project navigator. We've got our class navigator. This word here on the left, or the flat version. And that matters more when we have more complex classes than I've created. We've got the ability to search. For example, if I'm looking for employees, which is one of my classes, you can see where it's used, how it's defined, etc. And that's the search tab. We've got the problem tab, which at the moment, since I've tried to write the code error-free, you're not seeing any, but this is going to be especially useful as you're working on your own things, as you do what I tend to do when I first start a new language, fumble with syntax. When it's running in debug, you can see by threads. Obviously, I'm not running at the moment. Here you can see your breakpoints you've got set. You can set a breakpoint quite easily by, where is it? Oh. By clicking on the line, and then we go to the breakpoint list. You can see where your breakpoints have been defined. And the last tab shows all the times that you've run this, run the program. As you can tell, I've run this a few. You can see your history of compilation and builds and whatnot. And as you can see, I've fiddled with this a little bit. But the biggest thing, and we'll go over this first, is under Preferences. You can see your downloads. When you first install Xcode, let me zoom in a little bit. When you first install Xcode, you're going to find that you don't have half the documentation. Documentation is really key. It gives you everything that you could want about the iOS SDK, as well as some of the Mac libraries. The other components that are useful are the various simulators and debugging support if you're going to work with devices, which unfortunately don't come standard. I think the only thing that comes standard with Xcode is I haven't updated to 4.3.1. Is the first simulator and the iOS 5.1 library. Everything else has to be downloaded. It takes a little time, depending on your connection, but I recommend it highly. And there's two ways to get access to the documentation. One is in your code. If you hit Option, and your mouse will hover, and you can see that that it changes. And if you click on a class name, it gives you access to the documentation. This is one of the best things that you get out of Xcode IDE when you're first learning the language, because you're going to see when you first create classes, create projects off of the four standards that we'll go over a little bit more next week. You'll see the view controllers and this gives you some good ways to get into the view controller documentation and see how things are done. The second way of getting access to the help documentation is under Window. There's the organizer. And let's actually click on the correct thing. And under Organizer, you've got all your documentation, which you can search through or walk through some of the samples from Apple. Apple gives, as David said, gives you a wealth of documentation and examples, which really does make life a lot easier when you're trying to learn everything from how to set up a table view to how to use the address book libraries, which some of you might want to do for your iOS student choice projects. You can either walk through the titles, or you can search for what you're looking for. And for example, let me embiggen this a little bit. Sadly, regardless of whether it's local or not, if you look for something that's common, it's going to take a little while to pull up. If I'd been smart, I would have pulled up something that there's four examples of. And then as you look into things, whether it's you've got all the documentation right here at your fingertips. And obviously you can set your own bookmarks if there's something that you're going to come back to repeatedly as you're working on something. But the other thing that we have in Xcode is the GDB debugger. You can see there's. Let's start this. This switch here turns on or off whether you're going to be running in debugging. Once it's on, you'll notice that your breakpoints become active. And when you run your code to, actually, I made the mistake of, oops. This code brings up in the iPhone, but we'll ignore that for the moment. Oh, sorry. And once again, proving that live demos are just not fun for anybody. Let me pull up my code. Let's set the debugger. All right. All right, so we run this again to see the debugger. The debugger pops up on the breakpoint that we've set. And once in the debugger, you can examine any of our variables. In this case, and you do this by using PO. Is that big enough to see, Chris? PO for printout, and then the variable name. And first name is one of the variables that's being passed into this function. So we can see both the memory location, and the value. And once you're in the debugger, this is the console. Right here we have the console. We can either use the buttons to step over the code, step into the code, or whatnot. And as it steps, you can see the indicator giving you an idea of what line you're on. Or if you don't want to use the buttons, you can do it from the command line. The debugger is pretty self-explanatory if you've used GDB before in other instances. I just wanted to go over it quickly to show people how to do it. We've got in the slides, I've got some more information on it with all the commands and whatnot. All right, so we've got we've seen the log area. We've seen these areas of Xcode in the brief little bit that I was in Xcode. We'll see it further when we're looking at at the programs we're running. We went over where to get the help in the simulators. Went over debugging, and let's jump into Objective-C a little bit here. One area that David talked about a little bit was Clang, but not how to change which compiler you're using. So that's done for any project that you're creating. Let me make this a little bit bigger. You can change your build settings and choose a little bit more of your settings. At the standard, this is the standard that Apple goes with. If for some reason you're linking with a older library, you might want to change the compiler. But that's pretty much varsity work for your iOS projects. But I just wanted to make sure that we briefly touched over where you change your settings. It's going to be more important. You're going to get a little bit more of this with David in the coming weeks for iOS. But I just wanted to make sure that as we talked about the different compilers, you knew how to change them. For the most part, for this class, you're not going to want to, but some of you are going to be working with third-party libraries. There's a number of them, everything from 320 to some of the all-seeing eye HTTP asynchronous HTTP libraries out there, and you might have to deal with different compiler settings and whatnot. So this is where you do all of your setup for your project. Next week, when David brings in more of the iOS with the MVP, it's MVP, model view MVC, model view controller, you're going to see a little bit more of what can be set up and how. So back to our. All right, the primitive data types, we glossed over those briefly in class. We've got the int float, the ones that we're expecting. The big thing which David talked about briefly is let me use this. The ID, which is anything that at its lowest base is an NS object. And the most important thing to remember with an ID is the strength and weakness is that it can handle nil, and anything coming to nil will come back with 0 or nil for the message that comes out of it. For example, if you have a nil NS mutable array, which we talked about briefly in class, and you do the count to find out how many objects there are in the array, if it's a nil object, it's always going to come back as 0. We'll get a little bit more to that deeply in class, but I can't count the number of times where I've chased down a problem with iOS code, and the issue was somebody, because it doesn't blow up like it does with Java when you send something to nil, and we'll be seeing odd mistakes that shouldn't happen in the production environment because we didn't correctly check to see whether we've got nil. So the nice thing is you don't have to, and a lot of your code will continue to work. The downside is sometimes you want it to give you a clue, and you're not doing the proper checking. Much like with Java, NS strings are not a primitive type. The biggest thing to remember is you do have to have the @ sign at the beginning. The first week when you're doing your iOS programming, you're going to forget the @ sign, and you're going to get all sorts of errors in your code until it becomes muscle memory. And then when you go back to Java, it'll bite you in the other way. That's just the way it is. With logging, we've got NS logs, as David went over. The nice thing with NS logging is that it's got formatting, and you can format your messages a little bit better. And in the class, we've got the interface defined in your .h files. I'm not going to go too much over the defining your instance variables. I'm a firm believer that use property and synthesize. Let it create the setters and getters and create the instance variables for you, so that you don't have to. We spent 20 minutes in this today, and that's probably the only time you're going to spend time on it this semester. Use the properties and the synthesizers, and make your life a lot easier. David talked briefly about the interface with the I'm blanking on the word that he used. Where you've got an interface with we'll see this in my code. Before an implementation, you can extend the interface with a counterpart, or I forget how it was called, but to extend the interface. It's both. He's going to go over it a little bit more next week, but the big use that I've seen for it out in the wild has been to extend a class. For example, before 5.1, JSON wasn't part of the iOS SDK. So a lot of people implemented JSON by extending the NS string class with JSON functionality that would write back and forth to an NS string. And the other use that I see for extending the interface is to have pseudo private methods, which we'll go over a little bit more in my example, for a class, and we'll see that in a couple minutes when we go over the examples. Properties, we get our getters and setters, nice, simple. We've already seen the use of properties and synthesizing, and how simple it makes life, while we've still got the ability to call the setter and getter directly. David went over the properties attributes, so all this is just more back up to make sure that everybody remembers what David went over. The one thing that I do have here, and this is my fault, with once you're using Arc, which is iOS started in iOS 5, is the automatic reference counting. You don't use retain. You use strong and weak, which David will go over a little bit more next week. But retain is a carryover from when you had to deal with memory management yourself. So you had to retain to increment the count of things that you're holding on to, and then release to decrement the count of the things that you were no longer using, and then you had to explicitly dealloc it. But thanks to the magic of Arc, all that's gone, and you're back to, and you've got the equivalent of garbage collecting as we see in Java, which just makes things a lot easier. That said, it's still new for iOS, and I've heard stories about how it's not quite. There's some issues if you're doing for some of the things that you're doing, but I'm sure we're gonna hit that a little bit more in class this semester. But let's take a look at the method arguments. As David said, it's the one hand, it's kind of self-documenting and makes it a little clearer. On the other hand, you also end up with a 80-character line of arguments for your call, which can be a bit cumbersome. Personally, I actually don't mind the long arguments, because I think what it makes up for with cumbersomeness. It makes up for, also gives you clarity, which goes a long way to make things a lot easier when you're looking at code after 3 weeks away. The one thing that I'm not sure if David went over is when multiple arguments. This really doesn't matter. You're never going to see it except in the call, but it does it. All it does is give you some clarity of arguments. The only things that really matter is the return argument, each of the the return value, each of the argument types that go into the method message, the message to the method. Again, all methods, all calls are method passing. Nil accepts any message that you send to it. And because the message receiver is resolved at runtime, there's no type checking or anything. You can send whatever you want in the code. You will get some warnings, and I'll generate some of those in the example to show what I'm talking about. That gives you a hint that the object may not accept the message that you're sending to it, but there's nothing stopping you from doing it. Instantiating classes, it's a standard alloc init, as we saw in class, and you can also use their custom inits. There are also some convenient methods, such as new. And what that is the equivalent of doing an alloc and an init. In my example, I use alloc init and new interchangeably, so you can see that there's really no difference. But I think it does make things a little cleaner in the code, and we'll see that a little bit more once we get to the code. Again, for this class, we're working with Arc and not really delving too much into retains, release, auto release, and dealloc. But I think David next week, when he talks about memory management, is going to give us a brief visit into this, much the same way as before we got to property and synthesize. He showed us writing the getters and setters before you could do it the easy way, just so you have an understanding of how things fit together. Is that a question? Using other classes, interfaces and implementations need to know about other classes. You can use @class to define a class forward that will then be used in your in your definition. For example, if you've got a class that has that takes arguments of another class. I can show you an example. For example, in David's student example, you could have the concept of a class. I'm sorry, a major that a student has as another class, and that could be referred to forward, so that and we can see that a little bit in my example where I give a forward definition of something as an argument. In a string, before you get to the the Apple documentation is spectacular, gives you lots of information. But the big things to for quick takeaways is length for the number of characters in a string. That could be handy if you're looking for like the fourth letter, which may prove useful in the student choice project. I'm sorry, not the student choice, the first iOS project when you hear about it in a couple weeks. NS strings is going to be especially useful for you. And some of the things that are going to be useful is knowing how many characters are in a string, how to pull apart a string, and obviously string comparison. As David went over in class, there's the NS array, there's the collection classes of the NS mutable array and the NS array. It's especially useful being able to, there are some a snippet of the information you're going to find in the documentation that gives you some of the useful things that you're going to need when you're walking through some of the collections. You want to know how full it is. You're going to want to know if it holds what you're looking for, and you're going to want to be able to pull out the object that you're trying to find in your collection. You're also going to obviously want to add and remove objects from a collection. The other really useful collection that iOS gives you is the dictionary, which is, as David said, the equivalent of a hash map or an associative array, where you've got key value pairs that cannot be primitive classes. So again, it has to be an NS number rather than an integer or float or double. But you can find all of your keys, all of your values, and you can pull up the object for each of your keys. The dictionary can only have a single value for one key. So if you, for example, ever need to have one key having multiple values, there's nothing to say a dictionary can't hold an array or an NS mutable array, so that you can simulate multiple values for one key. But as anyone that's used hash maps or any of these types of collections, that there's always a way to work around a limitation with these collection classes. Now we're going to get to the sample code. So basically, it's a simple class.
Can you just make your font bigger?
Oh, sure. Oh, it's shrunk it again. Sorry about that. Oh, no. Son of a goat. All right. It's just a little bit more legible. Sorry about that. So working with what David went over with class, we've got, we do it nice and simple with obviously here instead of retain I should have used copy or possibly strong. This clearly shows that when I learned iOS we didn't have arc. So we've got we've defined a person as someone with first name, last name, and a ID, and a Harvard ID. We set up a custom initializer to make my life a little easier, and we added print me, which I'll go over in when we walk over this, to give us the ability to log information. In the implementation file.
I have a quick question.
Yep.
That thing called init with first name, is that's something you're just creating? That's not like a built-in.
No, that's a method that I created because the question was whether init with first name was something that was standard, and it was something that we created, but we created it with the standard naming conventions. They recommend that obviously any initializer function has to return ID, and one of the standards that for iOS and for Apple programming is that any init function begins with init. The other thing that we're going to probably see a little bit more in class is that the minus sign shows that these are instance methods. If there was a plus sign in this location, it would show that it's a static method where the class doesn't have to be instantiated. We're going to see more later in class that another type of helper function could be a create class, and let me, we're going to get to it later in the class, but it falls nicely within your question of doing something like this. And the standard naming convention is is obviously use a plus to show it's a static help convenience method for creating. You say what the class is that you're creating, and then you do the standard as we saw with the init. And we'll show how to use this again as we expand this. When we look at the implementation file, where is it? Oh, I should probably show people this. One of the with Xcode, there's a couple of really useful things. We've got the ability to see both the, where is it? There it is. To see both the H file and the implementation file at once. That really becomes a lot more useful if you've got a bigger screen. With the small size of the screen that you're forced with when it's displaying, it's nice, but it's really not going to help you much. But being able to the other thing that you can do. Let me pop this back to 1. Is control command up arrow will swap back and forth between counterparts, and you're going to find that very useful as you jump back and forth between the two files that you're editing, unless you've got a big the monster monitor at home, and if so, you're luckier than me. I talked briefly of extending the interface in the implementation file. And if you put something here, I think he called it a counterparty, or your implementation also has to have it. If you leave it blank, this is just a standard extension of your definition. The nice thing is, because it's defined in the M file rather than the H file, nobody outside of this implementation file can see any of this. So my private ID or my log data helper class can't be seen by anyone other than this. I'll show you, the compilation blowing up because of it. But the nice thing with defining your private methods here is you get if they're missing. Like, for example, we're getting a warning right here because the new method, public method, create person, blah blah blah, that I put into the H file isn't here. And if log data wasn't here as well, and this just gives you a quick heads up that this file is not complete. Did you have a question, Carl? Okay, sorry. Here we just use our synthesizers. We set up our IVARs using the Apple standard of an underbar at the beginning. We also synthesize our private variable that can only be seen inside this class. For this example, this is just to show that it can be done, not that it really does anything. Two things I wanted to do. First, we see the errors, and we see that now that we have an error. We can see that we've got the let me embiggen this. That's an incomplete implementation of this class, which stands to reason because we just added something to the H file and it hasn't been put into the code yet. And then secondly, when we try to create the function, is as soon as you start typing it, the nice thing with the IDE, it will fill it in for you, and just a tab, and boom, you've got your full definition from your method. Actually, and then because this is a static class, we can't assume that we exist yet, so we have to create ourselves. And you'll notice that the IDE is smart enough that when I hit the closing bracket, it popped another bracket over there. One of the nice things with Xcode is it, because it understands the syntax enough to do some code fill in for you, which can make your life easier. It can also drive you nuts if if it goes down the wrong path. If you've got a lot of files with a similar file name, but hopefully that's only going to be a big problem when you've got a huge project. I've seen a project with 1,200 files. As that, unless you were very strict in your naming conventions, it does tend to stumble over itself a little bit. Oops. Okay, so we've created a static helper function that does both the allocating and the initializing of a sample code 01 person record. This is going to become a lot more useful with UI elements, but it worked nicely off of Tim's question about initialize. And I can show how that'll be used when we get to the im file. The the inits, as David said, there's a number of ways to do things. We can use the dot notation, which is actually calling the setter. We can explicitly call the setter. We can do the not recommended choice of dealing with the ivar itself. As David said, using the ivars makes a little bit more is useful and correct in a setter that's going to do some extra manipulation, but for the most part, you're not going to want to deal with the deal with your ivars. It's usually better to just deal with the dot notation and deal with the standard setters and getters you get for free with Synthesize. All this is really doing is setting our instance variables, and then logging them, and then this is more of a example to illustrate why I did something that you'll see once we get to the private log data method. In the private log data method, because it takes an ID, it can be anything. I log what it is, and if there's and this just does this as you saw with Android. You can print an object, but unless you define a toString, it's not going to pretty print the object. Objective-C is the same way. This is just going to print input class and largely give us a memory location, as we'll see in the log file. Then if it is indeed a person object, we pretty print it a little bit to give us more information. And then I added in a public access function that calls the helper data. And I'll show you why I did this when we walk to the next step in the code. The person class is it really doesn't do much, but it doesn't have to. Here's some example of using the person class. Let me close off the next. And let me do a third one. So you'll note, yeah, we don't have to do anything with that. You'll notice that here we do the alloc and the init. Here we use the convenience class new, which basically does an alloc and a straight init with not using our custom initializer. Because this is at that point empty, we have to explicitly define all the variables that would then be defined in the initializer. Because it doesn't have access to the private ID or log data, which we'll see in a second when I uncomment out these two lines, these two lines will generate errors because they're all private functionality. I added this new call. It uses the convenience method that we created, so it doesn't have to worry about allocing or initializing. And so here, if we uncommented this, we find that Private ID doesn't exist, and if we hover over the error message for log data, it'll also tell us that log data is not a public method, which is why I added the public wrapper of log data, print me, which prints everything out. So let's comment these two out and run this. In our log file, as I said, because it's not pretty printed, it just tells us this is the class, this is the memory location. After checking to see that it's indeed an SCO1 person, it pretty prints the data. We slapped in the log data with the constant, which I guess I do repeatedly, to show that log data, because it takes an ID, you can put anything that comes from NS object and it'll print it out. Chet call because it called it called create person, which is then called the init function. Charlie gets all the standard setup. Bob, because that was called by hand, its private ID is not set, and it also doesn't get to it doesn't have the initializer, so it's not getting the call to the string constant. Ignore this last bit about application windows. That's just because of how I created the project, which I'll show you. Well, David's going to go over next week for creating projects with the interface builder, so we'll wave our hands over this last bit. The next iteration of this uses the another class called, oh, hang on a second, please. Let me comment all this back out. Yep. Oh. No worries. All right, we take a look at NS Employer. And this is, a lot less bells and whistles than before. What we've added to this, is this big enough? Okay. Oops. There we go. Less bells and whistles. It's basically, I've defined an employer to have a company name, an array of employees, and a dictionary of projects. We've got our initializer, our custom initializer with various settings, or we've got public helper functions to define various define our instance variables. I'm sorry, not define them as much as populate them. Why is this bigger? But, and here we, it's simple based off of what we've seen before. We don't extend our implementation, our interface, so what you see is what you get. We synthesize to creating our IVARs. We call our custom initializer, and we've got, oh, nice. Another thing that Xcode will give you is the ability to fold your code so that when you're not dealing with it, you don't have to see it. I'll open this up so that we can actually see it now. Add employees just populates it. The big thing that needed to be here is we had to check to see whether employees had been created. If it isn't created, we allocate it. If we don't put in this check, what's going to happen when all these are called? I'm sorry. Yeah, they're all going to be ignored because, well, actually, that's not true. A person record would be allocated, but it wouldn't go anywhere. It would be allocated and then largely thrown away because we're sending it into a nil point. We're sending it as a message into a nil object. Same thing with projects. We allocate our dictionary, and then we populate it with the data that we've given it. The print functions. Nothing too out of the ordinary. The one thing I tend to always add anytime I've got a print function is the empty check, so that rather than get nothing if you've got an empty list, an empty array, we're actually seeing that it's empty. There's two ways to walk through an array. We've got the old style for loop where we're incrementing things and then pulling out the object at the index, or we've got the new style that David went over in class, where you've the equivalent of for each in some languages, where you're pulling out the one variable out of an array of that type. With arrays, you can pull out the object of the array with object at index blah, which gives us a person record that we can then grab the data from. The other way to do it is to just pile on messages into a class. The same way in Java you can do the dot this, dot that, dot the other thing, piling onto your call. So here we've got our project, which is our dictionary. We get the object for that key, and then we just send the last name method to that son of a goat, to that object. And
Can you repeat that last sentence? And I'm going to change taste.
Sure. So here we send the message last name to the object that we've pulled out of this projects. We know that it is a person object, but it's not clear that it would be, and we're not doing any error checking. And I'm going to show you what's going to happen. First, I'll show it working, and then I'm going to change this to something else to show it how this can bite you in the bite you. And again, this is why it's a classic bad programming, but you don't want to do it this way. You always want to error check. So when we run this, we see that. Well, let me show you what's actually happening. Then I'll show you what we're seeing in the log file. So all we're doing is we're creating a new employer, which does the equivalent of an alloc and an init. We're printing it out, which unsurprisingly should probably print that both of these are empty. We're populating it, and then we're printing it. When we look at the data, we've got an empty employee list. We've got no company name, and we've got nothing in the dictionary, which stands to reason. Then we call the various inits for our employees, which then these will be populated. This is a little odd until we look at the code, which because, oops. Because the question is, why are these people being called before the rest of this? But we'll take a look at what's going on upstairs at the same time. So, because we give it the company name, then we add the projects, and the act of adding the projects also calls the initializer for our person class. So that's why we're getting the people being logged as they go through. So then we print off our employees, we print off our projects, and that's and I just wanted to go back to where we were changing where we were printing the last name, and if you pass in an invalid class, an invalid message which there is no selector for. Oh, nice! It did catch it. Excellent. All right. So I guess it's not as bad as I thought. It used to be that there was the ability to pass in a message that wouldn't have been valid, that wasn't valid, but with the new version, an NS dictionary keeps track of both of the instances. So this is being caught now. So this isn't as bad as I thought it was, because you don't need to check for it already does a quick check for the selector that you're sending, which I was afraid that it wasn't doing. So what this is saying is there is no method for other last name, and if we scroll over to the side, oops, let's see if it's over here. No instance. All it says is that the method doesn't have no known instance methods for the selector other last name. Actually, let me just set up an edge case just to see if this does what I think it's going to do. So we go to employer. All right, so now this goes away because other last name does exist in our project as something that can be sent to one of our classes. This class, because it's a person, won't accept it, and this should generate an error for us. We'll see in a second whether it does. Excellent. Cool. It is caught by the. It is caught by the. Let me begin that so that you can see it at home. Clang does catch it, which I didn't think it would. So it's gotten a lot more robust. Objective-C and Xcode has gotten a lot more robust about catching some of the. And to be honest, this was clearly a contrived example, but I'm very happy that it's catching these. Unfortunately, the error you got, it's hard to map this to the cause of the error that you got, but that it catches it is a good thing. So to recap, what I did, the original reason that this gave as an error was that none of my classes had this as a message. I added this to this class to generate to clear that, to see if this would generate a runtime error. What it didn't. What it did create was a compiler error for this. Unfortunately, that is the type of error that you'll spend a lot of time trying to track down, because this doesn't give you any indication whatsoever that this is what caused the problem. This makes much more sense as a runtime error, because what you'd get is at runtime, you'll send the message other last name to an object, which then which is resolved as a, not up on the screen, one of my person records, which can't handle it, and then I'd expect to get an error, bad access error, invalid message sent to class. But it's nice that it caught it. It'd be even nicer if you had a meaningful error condition. I had heard that there were some buggy cases with 431 from one of our developers at work, but I hadn't done much with it myself. And oops. And this is clearly one of those edge conditions with Xcode. David found a few last semester, and I can guarantee he'll find more this semester. The Apple support forums are alive with complaints about Xcode. That's it for the evening. Does anybody have any questions? We can go over them now. All right. Good luck with Xcode and iOS. Hope you guys have as much fun as we do.